Okay, so when you're identifying the mean and the standard deviation of the sampling distribution, we always have to figure out, am I talking about proportions or percentages, or am I talking about means, raw numbers? So I know that X bar always goes with means. P hat goes with proportions. So because I know that we're dealing with means, I know that the mean of X bar is going to equal the mean of the population, so mu. So when I go up here, suppose that among the population of smartphone owners with 16 gigabytes of storage, the mean amount of storage used is 13. So that is my sampling distribution mean. It's always centered at the true population mean. And I know that this is the standard deviation of the population, or sigma. So to find this, you have to remember I use that formula sigma over the square root of n. So I know that the population standard deviation is 3, and it's a simple random sample of 50. So I'm just going to calculate 3 divided by the square root of 50, and I get 0.42426, so we're rounding to 1 decimal place, so 0.4 is the standard deviation. Okay, so on this one, I can tell that we are going to be using that z-score. So according to the 2011 National Survey of Fishing, Hunting, and Wildlife Associated Recreation, there were over 71 million wildlife watchers in the U.S. So that's my population. Of those wildlife watchers, the survey reports that 80% actively observed mammals. Suppose that one of the census workers repeated the survey with a simple random sample of only 500, so that's my n because that's my sample size, in that same year. So this is my true proportion, P. According to the original survey, 80% claim is correct, so that's my P. What is the approximate probability that between 79 and 81% of those 500 sampled wildlife watchers watchers actively observe mammals? So I'm just going to draw a quick sketch. So here is my true mean of 0.8, and we want to know 79% and 81%. So we want to know what's between those. So when it's between, I have to calculate 2 z-scores and then subtract their probabilities. So I'm going to start with the z of the first one. And so it's always observed minus mean divided by the standard deviation. So in this case, my mean is 0.8. My observed in the first one is going to be 0.79, and the second one is going to be 0.81. And remember, with proportions, my standard deviation is that really big square root of p times not p. So if p is 80%, 1 minus 80% is 20%, divided by my square root of n. So I'm going to calculate that out. So the square root of 0.8 times 0.2, and in the denominator I have 500, so I'm going to get 0.0179. We'll just use that for our standard deviation. All right, so my first one is going to be 0.79 minus the mean divided by the divided by the standard deviation. All right, so 0.79 minus 0.8, so it's below the mean, so it should be negative, 0.0179, and I get a z of negative 0.56. So I'm going to do my second z, same thing, observed, so 0.81 minus my mean divided by my standard deviation. And this should be positive because it's above the mean. Divided by 0.0179, and I get 0.56, which makes sense because they're each 1% above and below the mean, so they should be a positive and negative same distance of 0.56. So now I'm going to go to that Z table and get each of those probabilities. So what probability is associated with being 0.56 below the mean and 0.56 above the mean? So I'm going to look those up real quick. So to find the difference, I take 0.7123, that upper probability, and I subtract off what's below the lower, because I'm looking for the difference, and I get 0.4246. So that is the probability of being between. So we were looking for the probability of p hat being between 0.79 and 0.81. So all of these are the correct notation. So now I'm simply finding 0.42, and so my answer is A.